Hello, good morning, and today we're going to be reacting to dark matter and dark energy. So yeah, stick around for the video. Let's go. Yeah, today I think we're doing a physics video today. I'm not sure if dark matter or dark energy counts as physics, but yeah, we're going to watch this video, see what we learn. So let's dive in.
Matter as we know it. Atoms, stars and galaxies, planets and trees, rocks and us. This matter accounts for less than 5% of the known universe. About 25% is dark matter and 70% dark energy.
So yeah, 5% of the universe is matter. Crazy. I guess that means, you know, we'll just 5% of everything. But you know, 5% is still good.
Both of which are invisible. This is kind of strange because it suggests that everything we experience is really only a tiny fraction of reality. But it gets worse. We really have no clue what dark matter and energy are or how they work. We are pretty sure they exist though. So, what do we know? Dark matter is the stuff that makes it possible for galaxies to exist. When we calculated why the universe is structured the way it is, it quickly became clear that there's just not enough normal matter. The gravity of the visible matter is not strong enough to form galaxies and complex structures.
So yeah, if you made it this far into the video, make sure to put dark energy in the comments, and yeah, it will really boost the algorithm. Thanks.
Stars would more likely be scattered all over the place and not form galaxies. So we know there is something else inside and around them. Something that doesn't emit or reflect light. Something dark. But besides being able to calculate the existence of dark matter, we can see it, kind of. Places with a high concentration of dark matter bend light passing nearby, so we know there's something there that interacts with gravity. Right now, we have more ideas about what dark energy is not than what it is. We know
so this video, I guess, is gonna be just speculation, because yeah, no one really knows what dark energy is, but yeah, hopefully this video will shed some light on what it could be, what it definitely isn't, and maybe answer some unanswered questions, and probably give you more questions that we'll try and answer in the next video.
Dark matter is not just clouds of normal matter without stars, because it would emit particles we could detect. Dark matter is not antimatter, because antimatter produces unique gamma rays when it reacts with normal matter. Dark matter is also not made up of black holes, very compact objects that violently affect their surroundings, while dark matter seems to be scattered all over the place. Basically, we only know three things for sure. 1. Something is out there. 2. It interacts with gravity. 3. There is a lot of it.
So technically, if it interacts with gravity, we should, in theory, depending on how heavy it is, be able to interact with it. I think I'm just waffling. I'm gonna just play the video.
Dark matter is probably made up of a complicated exotic particle that doesn't interact with light and matter in a way we expect, but right now, we just don't know. Dark energy is even more strange and mysterious.
So, since this image is a lie, that sucks. But you know what doesn't suck? My Discord channel doesn't suck. So yeah, you should definitely join it after watching this video. And in my Discord server, you can see when all my latest posts are. You can... Yeah, I'm gonna cut this part out of the video anyway. It doesn't matter.
We can't detect it, we can't measure it, and we can't taste it, but we do see its effects very clearly. In 1929, Edwin Hubble examined how the wavelength of light emitted by distant galaxies shifts towards the red end of the electromagnetic spectrum as it travels through space. He found that fainter, more distant galaxies showed a large degree of redshift. Closer galaxies, not so much. Hubble determined that this was because the universe itself is expanding. The redshift occurs because the wavelengths of light are stretched as the universe expands. More recent discoveries have shown that the expansion of the universe is accelerating. Before that, it was thought that the pull of gravity would cause the expansion to either slow down.
I don't know if you knew this, but I don't think the video is going to say it, but in the opposite direction, instead of redshift, there's this thing called blue shift. I'm not exactly sure how to see it, but yeah, there's redshift and blue shift. I think it gets bluer the closer it gets. Or maybe that's just because there's less red light. I don't know. But yeah, let's keep watching the video.
Or even retract and collapse in on itself at some point. Space doesn't change its properties as it expands. There's just more of it. New space is constantly created everywhere. Galaxies are tight-bound clusters of stuff held together by gravity, so we don't experience this expansion in our daily lives, but we see it everywhere around us. Wherever there is empty space in the universe, more is forming every second. So dark energy seems to be some kind of energy intrinsic to empty space. Energy that is stronger than anything else we know, and that keeps getting stronger as time passes by.
Alright, I'm gonna test you guys. If you know what intrinsic means, pop it in the comments. Don't lie, I'll know. If you know what intrinsic means, pop it in the comments. Just don't lie about it.
Empty space has more energy than everything else in the universe combined.
Just take a sec from the
We
word.
have multiple ideas about what dark energy might be. One idea is that dark energy is not a thing, but just a property of space. Empty space is not nothing, it has its own energy. It can generate more space and is quite active. So as the universe expands, it could be that just more and more space appears to fill the gaps, and this leads to a faster expanding universe. This idea is close to an idea that Einstein had back in 1917 of a concept of a cosmological constant, a force that counteracted the force of gravity. The only problem is that when we tried to calculate the amount of this energy, the result was so wrong and weird that it only added to the confusion.
I'm not gonna lie, I don't know how I would calculate a cosmological constant, because yeah, I don't know how I'd calculate that. I'll figure it out and talk about it in a later video if you guys are interested in that. But remember to join the Discord. Just remember to join the Discord. If you don't do anything else, like the video, subscribe, and join the Discord. If you're not a long videos type of guy, then you can just watch the shorts instead. It's just 60 seconds. I'm not just gonna be like one of those guys that make a 3-minute short. Just watch the shorts if you have to. But yeah, let's keep watching.
Another idea is that empty space is actually full of temporary, virtual particles that spontaneously and continually form from nothing and then disappear into nothing again. The energy from those particles could be dark energy. Or maybe dark energy is an unknown kind of dynamic energy fluid or field which permeates the entire universe, but somehow has the opposite effect on the universe than normal energy.
Yeah, I'm not gonna lie, I don't think the universe looks like a motherboard, like, with all the technological, electronical stuff. But who knows? I've never been to the edge of the universe. I may never go to the edge of the universe. If I go to the edge of the universe, I will record it and show you guys, assuming I don't die. But yeah, let's keep watching the video.
In matter. But if it exists, we don't know how and where, or how we could detect it. So there are still a lot of questions to answer. Our theories about dark matter and dark energy are still just that, theories. On the one hand, this is kind of frustrating.
This is my first reaction video. Don't really know what I'm doing. Just trying this out. Don't fault me for not knowing what I'm doing. I'll figure it out. Just subscribe to the video. It'll get better.
On the other hand, this is frontier science, making it very exciting. It shows us that no matter how much we feel we're on top of things, we're still very much apes with smartphones, on a tiny fragile island in space, looking into the sky, wondering how our universe works.
Oh yeah, that reminds me of a video I once saw that said that humans share 98% of the DNA of us with apes and chimpanzees. And chimpanzees, as you may know, are what we would call in the Stone Age, as they have figured out how to make stone tools, stuff like that. And people say that the smartest ape is the equivalent of, you know, your average day toddler, because what do toddlers do? They stack blocks, just like apes, I guess, stack stones. I'm not sure, but yeah, maybe aliens share 98% of the DNA that we do, and the smartest one of us might just be what their toddler's doing. Like, their toddlers may be just calculating astrophysics now. We never know. But hey, might just be us. So yeah, let's keep watching.
There is so much left to learn, and that is awesome. This video is supported by the Australian Academy of Science, which promotes and supports excellence in science. Learn more about this topic and others like it at nova.org.au. It was a blast to work.
I guess the video is done. So yeah, what we learned from that? Nothing really. I did not learn anything from this video. I don't know what dark energy is and dark matter is. I'll be real. All I know is we don't know what it is. And it is 95% of the universe. So, yeah. Subscribe, like, and I guess I'll see you in the next video. So, until next time. Goodbye.